I am making this quick video because I wanted to help out from earlier. We pretty much went over questions specifically about formal charge, and I really wanted to get a chance to share this with you guys so that you had an opportunity to understand why we were doing what we were doing, so I was able to get an answer for you. If anybody else is tuning in and watching this, we essentially had the question, and I'll zoom in right here. This molecule right here has a positive charge right here. And essentially, we all were trying to figure out why that was. And so I'm going to go ahead and break that down. So back in Gen Chem, and for me, this was forever ago, we learned about something called formal charges. Formal charges. And the equation for formal charges is equal to the valence electrons minus the bonds, or the single bonds, plus the lone pairs. Okay, and so this essentially, in order to answer this question right here, we need to understand what a formal charge is. The question was, why does this NH3 have a positive charge? And I'll get to that right now. So the reason why it has a positive charge is because of this equation. The formal charge is basically, back in Gen Chem, we learned about formal charges because we wanted to understand the stability of a molecule, and we wanted to understand the octet rule. So hopefully that's ringing a bell. But the main thing with formal charges is about stability. For amino acid purposes, later, which we haven't yet covered, we'll be taking a whole amino acid such as this one. We'll be taking a whole amino acid and we'll be placing it inside of a pH that's lower or greater than its pH. So let me get back to answering this question really quick. Let me erase all this. Okay, so long story short, formal charge will explain why this is positive. So the way that you do this is, do you remember, let's just take, for example, NH4. Okay, NH4. So if we take this molecule right here and we put it in the Lewis dot structure, you have N bonded to 1, 2, 3, 4 molecules, and then you have a positive charge. So you can ask that same question again. Why is it this has a positive charge? Well, there's a video that's on YouTube, and I'll make sure to share that below. But they make this answered by this equation too. It's the same equation, but it's just simplified. Its formal charge is equal to the valence electron minus B, which is just a bond, plus D, which is the dots, or the lone pairs. So if you look at the periodic table, and I'll pull up the periodic table real quick.